Welcome to Politically Incorrect course on machine learning first part. This is a test, so this is the first time I do this kind of thing. So if it's not good, well, remember it's for free, and so try not to be so harsh and critical, and try to see the positive side. That how to say that's my first, and also, like I said, it's free. And finally, that most likely you will end up learning some interesting stuff in this free course, and you will see why. Who is this course for? This course is meant for people who would like to start with the so-called data science, machine learning, artificial intelligence, and all those funky names that the market seems to use. The reason, the motivation, well, most likely if you got here, you were sick of, how to say, already seeing videos on YouTube that start with, yeah, this is a great course for the total idiot to machine learning. With this, you will learn very easy because I'm able to make it easy, and all of a sudden, all of this funky graphs and formulas and all that garbage starts to pop up, and you're like, if this is just how to say, idiot's guide to machine learning, I guess the not it's so idiot's guide to machine learning will have equations such as E equals mc squared or something like that. And the final reason is because, believe me, you will not use all these formulas. This is just mental masturbation, how to say, as simple as that. All those formulas are encoded in the softwares we use in this world. So at the end, what do you care how the formula is? It's already there. I mean, all you have to do is plug some numbers, try different numbers, try different algorithms. We'll see what an algorithm is. Different models until you have results that seem to make some sense. So what do you care about all that stuff anyways? And why politically incorrect? Like I said, because 99% of the courses out there use terms such as stochastic gradient descent. I mean, what do I care about those names, etc. And to me, the end result of those courses is that something that could be used for, I think machine learning is critical to society. It does a lot of good, and then it's not there, it's not available, it's still to a selected few. I think that's wrong, basically. And then the purpose of this course is to reveal the magic, just like that guy in the picture, with the mask, as you can recall from his 90s TV show or something like that. And then let the regular Joe be finally aware and able to enter this market. Who am I? Well, my name is Al Costa. I'm CEO of Tech and Trash. Tech and Trash is a company that what we do is a startup. What we do is basically to collect data from trash. So you throw something in the garbage, we are able to find it in the garbage and tell the manufacturer this thing belongs to this guy, and along with other things, etc. And to get all kind of data, all kind of metrics, etc. I'm professor at EAE, which is a university in Madrid. I teach big data machine learning over there. I have 5 books published in, how to say, internet, biofuels, machine learning, how to say, even a weird novel, and you're free to buy it. It's called Crusades. It's for sale in Amazon. You will be like the 5th person who buys it, and most likely, hopefully, and just a nice guy trying to help its fellow man. And why machine learning? First, because it pays very well. As simple as that. I mean, look at this graph from the World Economic Forum. The usual salary of a data scientist is 114,000 per year, by far the highest salary. A Kaggle master, Kaggle, it's a website in which people interact and they participate in contests, etc. A Kaggle master might be earning easily 130, 150, even 200. So it pays very well. Also because the people who work in this field are hard to fire because the company knows that it may easily take 6 months to get a guy. So you're not gonna let this guy go because you're gonna take another 6 months to replace him. And many times the end result is that the project will be stuck because this guy left with important information about the project, and until you find someone else who has that kind of knowledge, the project is not going nowhere. The team is demotivated because nobody's doing anything. So it's not worth it. I mean, this guy may be a crackhead. You just have to keep them there. Several jobs will be replaced by computers, so you better understand what all this stuff is, because you may find that it's not as hard as it looks, and you are able to actually jump into this thing, make more money, and not be replaced by a computer. And most likely because in this world you get to do really cool stuff and feel like you're doing good in the universe, or though you are the creator, the God Almighty itself, or something. So it's a good feeling. So let's listen to this stuff.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
Well, what you just heard was a demo by Google from a couple of years ago, I think. And then it brought a lot of attention, media attention, because this was actually a real conversation between a computer. The computer just called some local hair salon, and the lady who picked up the phone the other day, at the other place, was actually fooled into thinking that she was actually talking to a computer, and she's still waiting for this Lisa lady to show up for her haircut. So, can you imagine what would happen when this thing becomes commonplace? You will never know if you're talking to a regular guy or to a computer. I mean, if you work with computers with support or one of these cheesy 800 numbers that always say your call is very important to us, etc., you will likely be replaced. As simple as that. We will see later a technology called BERT that is able to read any text, also by Google, understand what the text is, and generate useful answers, just like a human being is. So again, this is powerful stuff. And you may say, well, a computer will never have the finesse, the sophistication of a human being. But I recommend you to listen to this. by now you got it. Maybe you don't like classical music, that's why I stopped it. But I totally see the Queen of England being coronated with this song. This is created by a startup called Iva. You can actually go to iva.ai and press click some buttons, and you in minutes it will generate a free song in rock and roll or something, so you can impress your girlfriend. Hey baby, listen, I created this song for you. Yeah, oh, you're such a poet, I'm so impressed with you, or something like that. So how to say, we are able also already we are able already to generate songs just like a pro, as you can see. This pretty chick in the picture, it's a pity because she's really pretty, but she does not exist. It was created by a technology called GAN, and you can actually see similar creative people at www.thispersondoesnotexist.com. With this technology, basically, we can create chicks, guys, whatever. We can create, how to say, portraits as Rembrandt or Goya or how to say, or Picasso, whoever, just by similar pictures. So okay, so all that stuff is very cool. So, but what is exactly machine learning? Okay, you got me convinced this is rock and roll stuff. Okay, so what is it? Well, machine learning is a subset of artificial intelligence. Artificial intelligence is, I guess the name speaks by itself. It has different areas, and machine learning is one that uses data. And this is important to understand because in artificial intelligence you have several techniques. The one that uses data as a trick, or how to say, as a ace card, is called machine learning. In the classical world, we tell the computer what to do. I mean, it's just a series of if something happens, then do something. As simple as that. You can create simplest systems as complex as you want with these commands. If something happens, then do something else. And in fact, many of these so-called artificial intelligence startups, at the end, many times you see that that's basically what they have underneath, which is not machine learning at all. I mean, it's kind of a rip-off, but their problem. But with machine learning, we have inverted the thing. Now the computer teaches us, the computer programs us. That's why the picture of the house upside down, because that's what it amounts to. Now we feed the computer with vast amounts of data and then let it do its magic, okay? Well, and what happens if we don't have the vast amounts of data? Well, in this case, you basically don't have machine learning, you're screwed. As simple as that. And you will see that obtaining the data, again, obtaining the data, and yet again, getting the data, obtaining the data is the hardest part. The hardest part is obtaining the data, and I cannot stress this enough. Machine learning is nothing new, actually. It's just based on stuff, statistical algorithms and how to say stuff that has been going on from the times of Blaise Pascal from the 1600. So you would ask, okay, so why only now? Yeah, because this guy didn't have computers at this time, did he? So, oh yeah, but we have computers for the past 20 years. Yeah, and many of these things actually started. You will see that a perceptron, which is kind of it's a simple neural network, was invented, I think, in the 40s or 50s. We'll see that. So, oh well, but why only 50 years after is when it's become commonplace? Because basically now we have inexpensive hardware. So the techniques are the same. The hardware is just that it's so cheap that now everyone can afford it, and big corporations too. It can be said that the real culprit in this world is China, because China was able to provide us with inexpensive hardware, and you will see that many of these algorithms, etc., are created by the Chinese. So in this world in the future, I highly recommend you to learn Chinese. I have my three daughters learning Chinese because I think that's gonna be a plus. Then, so the best way to start, the best way of doing things for me is to say what not to do, and I will follow this. So you will see this very common thing: 6 steps to a machine learning project. And the first step is identify a business problem that needs to be solved. I'm sorry about the company or whoever created this, but I I totally disagree with this. For me, this is so dumb. And I quote Henry Ford: "If I had asked people what they wanted, they would have just have said, well, faster horses." Machine learning is a new paradigm, to make it cool. It's a new way of thinking. It's not solving a problem or bettering something or fixing something. It's just thinking out of the box, doing something unheard of. It's not adapting ourselves to a new environment or something. It's just doing something that was unheard of. I mean, you probably have a laptop or whatever in front of you. I mean, go 30 years ago, nobody even knew what a computer was. There was a quote from a major player in the computer market that said that in the future there will be only 5 computers or so in the whole world, and this guy was a major name. So and there might be more computers than people today, honestly. So how to say, that's the power of machine learning. So to try to, like this thing says, identify a business problem that needs to be solved as a first step is just dead wrong. I mean, you're just missing the whole picture. You're starting off the left foot. So how do you start? Well, basically you let the computer fly. You let the computer do its thing, and you trust the computer. But I will not trust him. Well, you're not ready for this world yet. Then as simple as that. And then you may as well do this 6-step thingy, and you will find that you get mediocre results. And if that's what you want, fine. The dumbest way to continue. 99% of the data scientist professionals out there, and jobs, etc., and people who call themselves data scientists and job advertising for data scientists are just turbocharged programmers. That's what they're looking for. They just want someone who knows how to use and code in Python or in C or whatever for this particular software that they have, and produce software within X amount of time. That's just dumb. I mean, the name data scientist has a reason. It's because it's truly a scientist. A scientist follows the scientific method picture, which is you first ask a questions, then you do some research, then you construct a hypothesis, then you do a lot of experiments to try to to prove or disprove the hypothesis. You analyze the data, and finally you prove or disprove the hypothesis. In a corporate way, you always have to prove a hypothesis. That's not the scientific method. That's not being a data scientist. A data scientist, it can prove or can disprove something. So you do an experiment thinking that it could be that this thing, from a corporate point of view, if we do this thing, it could be good. And the computer says, no, it's not gonna be good, it's gonna suck. Okay, fine, you have to accept it. And we, many times in this world, we'll see that even though the computer says A, the top exec says B, and at the end, who's gonna win? Of course, the top exec. And that happens all the time. So again, this is not a turbocharged programmer. And the stuff that we see usually in coding areas, in coding sectors, and where you have several programmers doing, and things like teamwork, Scrum, which is a method spreading tasks among the different members of the team and expecting them to produce answers and results within a specific date range. They just don't make any sense. I mean, many times you don't even have an answer, you don't even have a result. So expecting a result X by Y amount of time, that's not scientific method, that's not data scientist. This is not how it works. Unfortunately, most of the companies do it like that. For me, it's a waste of money. Okay, so let's get started with what we would need. First, okay, we decided to start, and we'll follow what this guy says, and we'll let the computer do its thing, and we'll create a data science project, etc., and we'll try not to get on this guy's nerves, etc. Let him do the magic also, but he will need something to work on. Okay, first you need a hardware. And basically we have two main options here. You have a CPU or a GPU. A CPU is basically the brain of the computer. That's what you have in any computer, period. A GPU is a graphics processing unit, and you have it if your computer is good at playing video games. Maybe it has a label saying NVIDIA GeForce or something like that. Or maybe you already bought one of these good looking cards that always have a lot of ventilators on top, etc. And that's what we use, these video game cards. And you will think, why? I mean, because you play video games? No, because it happens that one of these GPUs is 1,000 CPUs squashed into a card. That's why they are expensive. But at the end, you will have basically 1,000 CPUs running on parallel instead of just one. So of course, it will make much faster. Up to 500 times faster than a CPU for training and for inferring. And now two words we can start. Training is when you get the data and you feed it to the computer and you train the computer. You basically teach the computer to identify the data and to try to make some sense out of the data. And inferring is basically when you already train the computer, you already, save the model. That means that you already have a file that the computer can use to analyze similar data, and you do it on a regular day. One thing is, and we'll see, you never end training. You should never do that. Once you start training, you will go on it forever. Okay, we'll see that later on. So even though you can consider the computer trained, this is never the case. You should always be retraining the computer. But nonetheless, it's much better, and you definitely should do that with a GPU. You can actually use even thousands of these GPUs for Bitcoin and mining and stuff like that. I mean, you have stores that have thousands of those things. And then you can have as many as you want. And it is funny that most of the data scientists out there, they don't even know how to use a GPU, and you go to talk to them and they'll say, we thought about it, but it's not compatible. They always tell you, that's garbage. It's always compatible. It's just that for some reason, there are a lot of the so-called data scientists out there are not using it, and it's just because they don't know and how to do it. And so don't fall for that stuff that is not compatible. That's just garbage. Okay. So the languages we commonly use here are mainly three. Actually, I'll pop a couple of later. But first is Python. Python is interpreted. That means that if you read the code, that's basically what will be executed. Yeah, at the end it will not, because it has to be translated to computer code, but you don't have to do that. Okay. It is very popular. I guess it might be more more common than R, and then it comes in two versions. The version 2, which is now obsolete but still used, and the version 3, which is supported, and the whole the market is moving towards it. R is a programming language. I don't know how to code in R, so I can tell it myself. It is also interpreted as Python. The good thing is that it comes with a lot of, how to say, libraries. I mean, if you want a library to calculate the amount of, how to say, flour that breads in Patagonia need to use, you can be sure someone has already created a library to calculate the amount of flour that breads are using in Patagonia or something like that. So that's pretty cool, okay? And that repository of all these libraries called CRAN, okay? C is by far the fastest. It's been around for, I think, 4 years or something, so it's by far is the oldest. It is compiled. That means that you have to, before using it, you have to create another software that it will be that software that will be executed, not like Python and R that you just execute what you created. It is fast, and it also comes in different flavors such as C++, C#, Objective-C, etc. It is very complicated, and then it is total nerd stuff. So, but if you really want fast results, you have to go to C. Don't go for Python and R. They are slow languages. Libraries that we commonly use. These two you will always see, NumPy and Pandas. I mean, every project always comes with import NumPy, import Pandas. Why? Because NumPy or NumPy, I call it NumPy, but it's NumPy, numerical Python, is a library that basically gets all the data that you're going to use and puts it into array, in memory, so you can play with it. So basically it loads data, and it can load it in several ways, or it can alter it, etc. So it's a must. You need to import it, load the data into memory, and NumPy will do that. Pandas, it's a subset of NumPy, and how to say, what it does is that it manipulates further the data and cleans it. So you will use Pandas for cleaning data. Now, there's something that I must warn you here. A lot of these projects fail because people don't know. They think, oh, the data is clean, or they even forget to clean the data. That's a major mistake. Always clean the data, never take the data for granted, and always use Pandas, because the data may look clean. The guy who gave it to you may say, yeah, this is awesome data, top quality, etc. Bullshit. It has a lot of nulls, it has a lot of stuff that is missing, etc. And Pandas is your best friend for that. Matplotlib, I can never pronounce this stuff. Matplotlib is I barely use this stuff myself. It's a library for Python which is used for drawing graphs. Basically, it gets all the data that was loaded by NumPy and shows you into a graph of X, Y, Z, whatever, and then so you can see it visually. That I don't use it myself, but how to say, everyone in this world uses it. OpenCV, which I use because I deal with imaging, I use this a lot. Basically, it's a library that allows you to import images, save images, turn images upside down, whatever you want with images. So if you're dealing with images, videos, etc., you will, yes or yes or yes, be using OpenCV. Natural Language Toolkit is something like OpenCV, I guess, but for projects that have to do with text. Okay, it can connect with over 50 corpora, which is a corny name for corpus, which is another corny name that we'll see later on. And then but basically NLTK allows you to connect to all these things, and how to say, and is used to for projects that have to do with reading text, etc. Frameworks that we commonly use. A framework is basically like a programming tool that will give you all the algorithms, all the things that you will be using to calculate and produce results. TensorFlow is by far the most known. It was created by Google and it uses tensors. A tensor is like a multidimensional array. We'll cover that later on because it actually, how to say, we need to speak further about it. It is used by major players such as Uber and Dropbox. You program in C and Python, but 99.9% of people out there use Python to program it. It comes with something cool called TensorBoard, which allows you to monitor and graphically what is it doing, as it's been trained or not, and another for putting stuff into production, which is how we call when you get something that's already programmed and tested and you put it to work on an everyday basis. And how to say, that's called TensorFlow Server. That's actually pretty useful, and few people know about it. So everyone gets all the coding and testing, etc. in TensorFlow, and use other stuff for how to say for production. That's just silly. I mean, you can use TensorFlow Server and how to say, it's so you don't have to export models, etc. So again, TensorFlow, everyone uses it. It was created by Google. You will see it whether you like it or not. Keras is basically a simplifier. The thing with TensorFlow is that it is a little bit complicated to program, so Keras is your best friend. How to say, it makes the coding much simpler. So if you're learning, if you're entering this world, most likely you will pass through Keras. It's also able to connect to Microsoft Cognitive Toolkit and Theano. These are two other frameworks that I will not cover because Microsoft Cognitive Toolkit, I don't see anyone using, and Theano is dead. It's been dead for like 2 or 3 years already. Again, Keras connects to these things and makes their programming useful, much simpler, okay? And I forgot about this stuff here. I said that I will cover two other languages. Another language that is used here is called Lua, and believe it or not, was created in Rio de Janeiro. It resembles C, but it's very complicated to use. It is very powerful. And the other, we'll talk about it briefly later on. And the other is called Julia, and for me it is the future, because even though it is interpreted, it is very useful, it is very easy to use. It has the power and the speed of C. So for me that's great. So you have the simplicity of Python and the fastness of C, and that's why I love Julia, okay? More frameworks that we commonly use. CAFE or Convolutional Architecture for Fast Feature Embedding was developed by the University of California, Berkeley. It's written in C++, so it is fast. I hate this stuff, honestly. I mean, for me, it's way complicated to program. You have to create different programs if it's going to run on a GPU or a CPU. How to say? I don't see this going anywhere. It's still used, but for me, it's going to die. Scikit-learn, that's another thing that is still being used. It is built on NumPy and SciPy. SciPy or Scientific Python is something analysis library similar to NumPy. I didn't cover it because it's used just by scientists really, and then like biologists, physicists, and stuff like that. Um, but it does not cover, scikit-learn does not cover neural networks and has no GPU support. For me, it's also a dead end. Okay. Also, I don't like it. PyTorch, it is very common, was created by Facebook, and how to say, and it's based on another framework called Torch, which I haven't seen anyone use. So, which was made with the complicated Lua programming language that I just told about. So the guys at Facebook thought, okay, this is an interesting framework. Problem is that in order to work with it, you have to use Lua, and not everyone knows or even likes the language, but everyone loves Python. So we're just gonna adapt it to Python. So that's why it's called PyTorch. Okay. And TF-Learn, I love this stuff. I mean, it's so easy. You can create how to say neural network. We'll explain that later. In just 11 days lines of code. I mean, not even Keras can surpass that. With TensorFlow, it will be like 50 lines. It's just like Keras. It makes your life even easier than Keras, but it only connects to TensorFlow. And then, but it seems to be dead. I haven't seen any update for this thing for the past 2 years. It is not very sophisticated. It does not have many functions, but nonetheless, if you wanna start if you wanna start with TensorFlow, I would recommend first you go to TF-Learn, after you go to Keras, and lastly you go to real TensorFlow. Okay, so what's the typical process in this world? The typical process is you first collect the data. Remember, I said many times, you need a lot of data. If you don't have data, you don't have anything to do, you go home, okay? So collecting data, data could be text files, databases, photos, porn, video, feeds from social media, all that's the data, okay? The better the variety, density, and volume, the better the results, okay? This is actually the hardest part. Believe me, it is. You go to a meeting with this top executive who is responsible for finance. And then he will want to know why you want this data, who are you, and then you tell him, well, the CEO sent me. And then, okay, so bring the CEO. Then you come back with the CEO, and the CEO tells this guy, listen, I'm the boss, you give this guy his data. Sure, Juana, I will do that. Then as soon as the CEO turns his back, he sends you data from 1744, when the hosts of the Greeks won against the Persians or whatever. Or data that is incomplete, or is full of no value, it's just garbage, etc. So in getting data, it's a nightmare, and you will need a lot of, politics in order to pass through this, okay? Second is preparing the data. There's a saying in this world that says garbage in, garbage out. That means that the computer will accept anything you give it to him. He will not complain, believe me. This guy is really nice and he doesn't complain. And by being nice, he's actually a dick, because you think that the data is fine because he didn't complain, and all of a sudden he tells you that the cure for AIDS is drinking turpentine or something like that, and then and you're like, okay, should I believe this stuff or not? And you got a problem there, because you go to the same CEO that backed you up, and you tell, well, listen, we found the cure of AIDS and it's drinking turpentine. And then he's like, okay, so you want me to believe that? Then most likely that same guy who didn't want to give you the data will tell you, oh well, I knew that this was going to happen, etc., because all this machine learning stuff, hocus pocus doesn't work, etc., and it's because you had dirty data. So getting clean data is vital, not only for for getting meaningful results, but also for saving your job. Because if you produce weird results, you will have to really support it and prove that the data was clean, that you took every measure possible to get to clean the data, and you only fed the computer with politically correct data. Okay. And in fact, this is I would think that 70% of the time you spend in this world is cleaning data. It's boring, boring, boring. For me, it's a waste of money, because you saw the salaries that we get in this world, and this is just a trainee could do it. But so in an ideal world, you only get data that was already cleaned by some cheaper guy. Okay. Okay, let me see. Then the second step is train a model. Basically, you get the data that was clean, you feed it to the computer, you give it tags or something. We'll see how that works. And then you split the data in two parts, a train and a test. This is important. The training data is the data that you use for training the computer, basically teaching the computer to be able to identify further data. And the test data is the data that you use, to actually see if this thing is working. So images, for example, you have 100 images of a Coca-Cola bottle. You train it with 70 pictures of the Coca-Cola in different positions, and after that, you show 30 pictures of Coca-Cola in different positions, and the computer should be able to say, okay, that's a Coca-Cola bottle. Okay. Since I work with images, most of the examples I will give are from images. Okay. So you split the you split the data in 70, 30, others split it in 20, 80, even 90, 10. I usually use the entire data, and because I work with images and I test it with a video. I just show in the Coca-Cola example, I just feed the computer with the 100 images, and I get a webcam and I show it a Coca-Cola bottle, and I see if it works. The more data you feed it with, the better. Okay, so you don't want to say, okay, I'll be democratic and I'll split it 50-50. That's just dumb. Okay. So after the computer told you that, okay, I think that I finally got it, and then we say that the term for that is, we say that the model converged. A model converges, that's a term you need to know, when the computer usually tells you that it has 99% accuracy. And what happens if the model does not converge? That the computer says, well, I can't go below 90%. You don't have to, to try to go to 99.99999%. Actually, there is a problem called overfitting, in which if we do this training too much, then many times the computer actually learns a trick, and then finally it is way too smart and becomes inflexible. So you don't want to overdo the training. That's what I'm trying to say. Don't overdo it. Don't think, I'm gonna trade this stuff forever. And then you will say, yeah, but you just said that this training thing goes on forever. Yeah, but it goes on forever with new data, not with the same pounded up data. So don't beat up on a dead horse. If the computer will not go between 2% or lower, you got a problem. Okay, then you can consider that it has not converged. If the computer says, okay, 99% I'm getting it right, then you can consider that, okay, I believe the computer, let's try it. Let's test it. And then you get the 10%, 20% of extra data that you left, and you feed it to the computer in order to see if what it claims to that it have learned, it makes any sense, okay? So you realize that, yeah, the computer was right when it said that 99% of the times it does recognize. I mean, we gave it 100 bottles and it recognized 99 bottles, and just one it didn't recognize. Okay, so we consider that it's a trained model, and we put it in production. Remember what that means? That is when we consider that this can go into day-to-day routines. Still, we always feed it with new data, okay? And that's improving the performance, okay? So again, never consider that this has an end. That, okay, I trained, I reached the apex, the Illuminati thing. No. Once you start training, you never stop, okay? So in the typical process, we'll see further what it means to be importing the data and choosing variables. Importing the required variables means that first, like I said, you always start with importing NumPy and pandas. You already covered those. Many times we don't do that, and we think, oh, this data is clean because this guy told us so. Or we even forget to clean up the data. Major mistake. Okay, you will find that many times the data is dirty, it's missing parts, etc. And then and also because you're saving your own ass, basically, because if at the end the results you obtain are no good, you can always say, no, I did my part. I cleaned up the data, okay? So basically the second step is, so the first step is importing the required libraries, NumPy and pandas into your, into your code. The second is importing the data set. Usually it is a CSV format, which has text files with fields separated by commas. NumPy, again, will create an array of the data, and pandas will clean it, okay? Since I use, in my company, we use images, we don't deal with the CSV formats and text files, thank God, because they are boring as hell. So we just deal with images, okay? If your company or whatever deals with analyzing, for example, computer feeds or something, they will give you feeds from Twitter or Facebook, etc. So the third step is choosing the variables. This is very important, okay? Let's use the Titanic tragedy, which is very often used as a model, okay? So as you know, most men died. I mean, that's a field chauvinistic ship or something, and then a female chauvinistic ship, because most people who died were guys. And then what happens is you got a CSV file with name, age, if this guy is a guy or a girl, age, if it's first class or second class. As you know, most people from first class didn't die, only the poor died, etc. So you got already a hint there. If the database has a value of whether the passenger likes cookies or not, I don't think that means much for his survival. Yeah, maybe if he likes cookies and nothing else, maybe he will die of starvation, but that's less important than being a guy or being rich or not, okay? So So example, the amount of cinnamon the passenger had in his diet. What's the point of that in whether or not he drowned? Okay. So after you chose the variables you're gonna play with and feed it to the model, you clean up the data, because many times you will see that when the passenger registered, the guy who registered the passenger forgot to say if it's a guy or a girl. So yeah, that should be clear that, yeah, but many times it happens. So in that particular field, you will find fields in which nothing was recorded. So what do we do now? You have two choices. You can just say 0. Okay. Suppose 1 is female and 2 is male. You cannot just give 1 or 2 because you don't know. So you just give it a 0, which is meaningless. Okay. Or in last case, you do a, how to say, you do a means between one and the record before and the record after, and then you do a halfway. So I guess between something in between, I don't know, transsexual guy or person, whatever, I don't know. And then that's not gonna work. So in this particular case, we just most likely will have to give it a 0. Okay. Normalizing and categorizing the data. Various variables must be normalized. In the Titanic models, we could have another table which gives us the amount of ice in kilos surrounding the Titanic. Yeah, that could be useful. I mean, the thing hit an iceberg, so knowing how much ice there was around could play a major role in this thing. Yeah. The problem is the thing is in kilos, and there must be gazillions of kilos of ice in where it was. So in the example, 15 people died. It's a real number. And then we feed it, the computer with the number of people who died, and 3.5 gazillion kilos of ice. It's not gonna work. The computer is going to, how to say this, all that ice is going to distort the model. So in this case, we need to cut zeros in the amount of kilos of ice, and then or turn it into tons or gazillion tons, or I don't know. So if it's so, in order to be in the three zeros range, just like the 15 people who died. Also, the data must be categorized. We just said normalize, that's a term, and categorize is another term. Categorize is when you give numbers to fields. The name, Simon, Joe, Susanna, etc. Those could be passengers, but you cannot feed text into the formulas. So you need to come up with a number to replace names. Okay, so you can, in this particular case, if you really need to use names for, because you think it plays a major role, you want to know, for example, how many Jonah died or something, and what's the relationship of being called Jonah and dying or not at the Titanic, you have to give numbers to all passengers. And so Jonah will be replaced by 228 or whatever, okay? So, and the next we'll cover, once we, how to say, we just clean up the data, etc. And the next we will be covering exactly what kind of models we can have, etc. I know it's being long and boring, but I hope you liked it. And remember, this is my first, so if I suck, please tell me, okay? And I'll try to do better next time. Thank you.